So in this video, I'm going to talk about the Apple research on AI and development using large learning models to read the objects on your screen, which they will be utilizing in Siri. A month ago, Apple scraps EV plans to shifting their focus on AI. Apple canceled the vehicle project. The company began to prioritize the artificial intelligence. As we saw in CES 2024, that tech giant is competing in who builds the AI first. So Apple is lagging behind in the AI world as compared to uh, Elon Musk, Samsung, OpenAI, Google, and Microsoft. And we know that Apple is a big company and they can do a lot more. And analysts suggested that Apple could see AI-related gains across its services and devices. And I saw the Apple Vision Pro that how they are utilizing the AI machine learning in different cameras, which was installed in the Apple Vision Pro, all the different cameras. And I have seen that how they are using brain waves, electromagnetic waves to see the state of mind during the processes, during the tasks. And we have recently seen that how Elon Musk used Neuralink to help a paralyzed person to control different and make sure to check first link in the description to build your online business. And now Apple has released this new research, which is and now the Apple has released this new search, which aims to take on GPT-4 with its ability to understand context clues. Apple researchers developed this new AI system to see and interpret context from on-screen content. The difference resolution as language modeling. Just the ReALM system allows for more natural interaction with the artificial intelligence. The researchers behind ReALM say it outperforms OpenAI's GPT-4 in understanding context. So now I'll have a short look on the research paper. I'll see its abstract and what the results they have achieved while comparing to other large language models and the results. And let's see how it goes. So this was the paper that was released by Apple on that is that is named as ReALM Reference Resolution as Language Modeling. So what this means is that the way the a current AI models, the large language models, work is that they trained a lot of text data to make the model capable of predicting what is going to be next. And in this way, when we write text, the model understands it and gives us the result. But now what they are doing is they are taking the same approach and training their model on the objects which are on the screen. So whenever you someone gives a prompt to Siri that do something on the screen, the Siri or their AI model will look at the screen and figure out what app to open or what make a phone call or open the camera, and it will do that task. So let's see what they have said in the abstract. So abstract is sort of summary of the research paper. The research is about making computers better at finding out what people are referring to when they say something. This includes things mentioned in conversation or items on a computer screen that aren't being directly talked about. While larger language models like GPT-4 are really good at understanding and generating text, they haven't been used much to figure out these kind of references, especially for the things that aren't text, like objects on a screen. So this paper shows how these language models can be really good at understanding these references by treating the problem like a language task. Even when it involves stuff that isn't just text, they made a system that's much better at this than previous ones, especially for items displayed on a screen. Even the smallest version of the system did 5% better than the old methods. They compared their system with GPT 3.5 and GPT-4, and their smallest model did as well as GPT-4. The biggest version of the system did even better than. I'll show you in a bit what the results they have achieved. So what they did was they used smaller models as compared to GPT-4 and GPT-3, and they got nearly as close results. So they showed the model the three type of entities. The entities are which are the important things which the agent or the model should take notice of. And on-screen entities are obviously which are present on the screen. Background entities are the ones which are happening behind the scenes, like alarm or playing music. And they describe the task as a kind of multi-choice question for the language model. The program needs to pick the right option or options from the entities shown on the screen. Sometimes the correct answer might also be none of. So the evaluation method means they're checking that how well it performed. To see how well the program is doing, they let it give the relevant entities in any order. So if the entities are 8, 7, and 4, the program gets credit if it picks any combination of these three, even if it doesn't get any order exactly right. The method they used to train the model was this. The data sets they used were like conversational, synthetic, and on-screen. So obviously the train data is always more 2.3K, 3.9K, and 10.1K. And the test data is always less, so it's more like 80-20% ratio, or it depends upon the task which you're performing the model for. So the data sources, the data sets were created either synthetically, means artificially, or with the help of human annotators. Each data point includes a user query and a list of entities relevant for that video. For example, if a user asks to call the mom, the relevant entity would be mom's contact information. The data collected for entities relevant to users' interaction with the virtual assistant. Annotators were shown screenshot with synthetic list of entities and asked to provide queries that clearly reference a specific entity where the user query and entity type are enough to resolve the references. And on-screen data are obviously the data collected from the web pages containing phone numbers, email addresses, or physical addresses, and annotators identify entities and provide queries for them, ensuring the queries sounded natural and referred to the virtual entity. They compared their proposed model realm with the two baseline approaches, one based on the re-implementation of the reference resolver proposed in Mars, which is non-LLM based, and one based on ChatGPT, both 3.5 and GPT-4. And here are the results that how these perform. So Mars with the conventional data set did 92.1, synthetic data set. So these are the three data set types, and here is the unseen data. So here is the Mars results. The GPT-3 performed behind, and GPT-4 outperformed. While the realm with the 80 million, 250, and 1 billion and 3, you can say window, performed a lot better from all these. So the GPT-4 constitutes like trillions, has window around trillions, while these you can say 80 million, 250 million, 1 billion, and 3 billion. These are way less than those. You can see how much they are performing. They're performing a lot better than GPT 3.5, and the Mars and GPT-4 are close to them. But the difference is that the window is very small here on the right, while in the GPT-4 is way too much. Same you can see in the synthetic data set that GPT-4 is way behind, GPT 3.5 is way behind, while the realm is performing a lot better as the size is increasing. Same with the while in the screen data set, the GPT-4 is close, and on the unseen data set, the GPT-4 performed the same. While the GPT 3.5 struggled on the. So yeah, let's see how Apple's integrates this into their Siri and how well they utilize the AI agents. And I made the last video on how Andre NG is has talked about, and some other people are talking about the AI agents and how well they can perform and reduce the human effort. So yeah, as always, make sure to like the video, subscribe to the channel, and make sure to check first link in the description to build your online business. And I'll see you in the next one.